Then after, the size of the nucleus. See, no doubt, in last chapter we discussed this thing, the radius of the nuclei, that is of the order of 10 raised to minus 14 to minus 15 meter, with the help of the experiment of alpha scattering by gold foil. But what is the exact or accurate radius of the nucleus? And no doubt, for different nuclei, this radius will be slightly different one. So how to calculate this radius accurately? Because see, in the experiment of alpha scattering, if we consider that alpha particle in Geiger-Master experiment, we discussed this thing. The alpha particle bombarded on the gold foil was with energy equal to 5.5 MeV. 5.5 MeV. But suppose we take the energy of these alpha particles that is greater than this one, then we get some less distance of the closest approach compared to the distance of closest approach obtained in this experiment performed by Geiger-Master. So actually here in this particular experiment, the results and the calculations all based on Coulombian force, right? But when scientists carried out somewhat detailed study related to the size of the nuclei, then they observe this thing. It depends on, no doubt, number of nucleons in the nuclei. So finally, the radius of the nuclei with atomic mass number A calculated as R equal to R0 A raised to 1/3, where R0, that is the constant, and its value, that is 1.2 into 10 raised to minus 15 meter, that is 1.2 Fermi. So radius, or we can say size of the nuclei, that depends on the atomic mass number, means total number of nucleons residing in the nucleus. Clear to all of you? Now see, we already discussed this thing. Almost entire mass of the atom is concentrated in the nuclei. So depending on the mass and the size of the nuclei, if you calculate the density of the nuclei, then that is almost equal to 2.3 into 10 raised to 17 kilogram per meter cube. It is almost constant for all nuclei. Tremendous large one. See, what is the density of water? That is 10 raised to 3 kilogram per meter cube. This one is of the order of 10 raised to 17 kilogram per meter cube. It implies that the density of nuclei, that is approximately 10 raised to 14 times larger than that of water. So from this one can understand easily this thing. What a closed pack structure is there in the nuclei. Clear to all of you? So this particular equation was derived with the help of the experiment of scattering of fast electrons bombarded on the different nuclei. Okay.